All right, good afternoon. How's everyone doing? My name is Roland Lee, and I'm part of Heimdall Data. Just want to level set with everyone. The topic of this session is automated SQL caching into Redis without code changes. I hope everyone here is interested in caching and SQL. If you deal with unstructured data, then this probably isn't the session for you, okay? Are we all here for the right reasons? Okay, all right. Well, what I'm going to do is I'm going to up-level even higher. It's just not only about SQL caching, which is definitely what a database proxy can do, but I'm going to explain how a database proxy in general, what it does and what are the benefits for you as a developer or DBA. So maybe I can get a sort of a show of hands. How many of you are developers out there? Okay, and how many of you are DBAs? Okay, a pretty good number. And everyone is interested in SQL or is dealing with SQL? Okay, all right. So let's start off. Heimdall Data is based in Palo Alto, here in the West Coast, and we are an intelligent database proxy. We're one of many database proxy products out there. There's quite a few open source ones. And I'm going to talk about a little bit about the concept of it and how it can benefit you, particularly as it relates to Redis. And then afterwards, what I'll do is I'll give a demonstration on what a database proxy can do, namely what Heimdall Data can do. Full disclosure, Heimdall Data is a technology partner with Redis Labs and with AWS and Pivotal. So we're all part of the same family here, and you have booths down there as well. So web scale challenges. What are the challenges as a developer and as a DBA that you face? On my right, your left, as users grow, you're going to have the application servers that need to scale out horizontally. But what's also difficult is really the data tier, the database. That also needs to scale. And those challenges with more users and more applications implies, obviously, higher data volumes, more tables, more changes to schemas. And then the third one I just highlighted there is higher latency responses, which if you don't come from a networking background, you neglect. And people think that if you deploy in Azure, you deploy in AWS, all these issues of networking is automated. Oh, security, all that stuff is taken care of. AWS is going to handle it for you. It's hosted, I don't need to manage it. But not so. One of the big things I'll just highlight right away is when you deploy applications in the cloud, there's high latencies. Think about it. As applications and databases are deployed in the cloud, they become geographically dispersed. That dispersion between the application and database creates latency, which slows down the application. Okay? So what do you do about it? One way to solve and scale the database and solve latency is to cache, by definition. So you can use a Redis cluster or use Redis to cache the SQL results. Does anyone do that today? Okay. But the challenge here, what's the challenge here of doing that? And this is going to be an open discussion, so we do have a mic. Yes? Expiring the data. What else? What else is the challenge? That's a very good one. Anything else of offloading the database through caching? One famous engineer said the two most difficult things in computer science. What are those two things? Anybody? Pardon me? Naming variables, that was tongue-in-cheek, but he meant it. Naming variables is difficult, and the second one is invalidations. Okay? So caching works here, but the thing is you have to code to it. And it's very difficult, it's risky, because you need to fool around with the time to TTL, the expiry, and you want to make sure your data is fresh. So what a database proxy is, or Heimdall Data, is that it's a data access layer that sits between the application and the database, and it can auto-cache and auto-invalidate into a Redis cluster. There's no code changes. So with a click of a button, you just logically it's in between the application and the database. Physically, what makes it very unique is that it auto-caches and auto-invalidates on the application tier. It runs as a separate process on the application, so it's distributed, as opposed to a hop on the wire in between that's centralized as a single point of failure. So each Heimdall Data piece of software is on each application server. They communicate together as one aggregate cache and caches into Redis automatically. Oftentimes I hear that I explain, well, a database proxy or Heimdall Data does automated caching and automated invalidation. And their first question to me is like, how are you different from Redis? Redis is a partner. What the proxy does is that you choose a storage of choice, whatever it is, in memory or Redis, and Heimdall Data provides the intelligence of caching and invalidation into the storage of your choice. Does that make sense? It's the logic. That's the difficult part. It's not the caching part. It's not the storage part. So you choose a storage of choice, and Heimdall Data caches into it. Any questions so far? So what the database proxy does, it tries to combine some point products together. F5 for load balancing and failover, New Relic App Dynamics in terms of its application performance monitoring, basically performance visibility, and then Proxy SQL. Has anyone heard of Proxy SQL? It's an open source database proxy, but only for MySQL. We're trying to combine all those things into one solution called Heimdall Data. And the difference is that deployment of this database proxy requires 0 code changes. There's no changes to your application and no changes to your database. And number 2, what makes it unique is that it's database vendor neutral. So whether it's MySQL, Postgres, Oracle, DB2, whatever SQL database you have, it's database vendor neutral. It's completely transparent. And the way that it's transparent is this is the software package. On the left-hand side, I think you'll understand if you are a Java programmer, Heimdall Data is basically a JDBC driver. It's a jar file that you put in between your current application and your current JDBC driver. You shim it in between. So to deploy Heimdall Data, it's just you just change the connect string. It just points to Heimdall Data, and then Heimdall Data will talk to your current JDBC driver. It's basically a 5-minute installation. Well, if someone says, well, I don't program in Java, I program in PHP, Ruby, Perl, or whatever other language. Well, in that case, we have a database proxy. And we can speak in Postgres, MySQL, SQL Server. And in that case, it runs as a separate process on the app server, and you just change the IP and port. It's just a networking connection. And again, there's no code changes whatsoever. Okay? Any questions on the packaging? That's what allows us to be transparent, either as a JDBC driver or as running as a separate process on your app server. Let's get into some use cases, which I think you'll find very interesting. The first one, as I mentioned, we can support is SQL results caching. This is distributed. The caching is done on the application server, and it auto-caches and auto-invalidates into Redis. No code changes. The second thing that it can do as well is it can do automated failover of your SQL database. It provides faster failover of MySQL or SQL Server. And it can also, for you Postgres users, it's also a PG Pool 2 and PG Bouncer replacement. Again, the benefit is you don't have to code and develop. The other piece, the third use case is horizontal scale out. As I mentioned, as your application grows, your data tier will grow. You can only grow your database to some level when you vertically scale it up, which is increasing the number of cores, increasing the hardware and the memory. Eventually, you're going to want to scale out your data tier horizontally. And the way that you do that typically is you separate the write servers from the read servers. Databases are stateful, so there needs to be some intelligence from the application to route the writes queries to the writes, the read queries to the read replicas. So typically, since writes are expensive, you want the writes to go to the writes. And when you're doing reads, you want to read from the read replicas because they're cheaper. But when you separate the reads from the writes, that requires code changes, application code changes. With the database proxy, you don't need to do any code changes. It's all a policy. Heimdall Data is SQL aware, so it knows the writes should go to the writes and the reads should go to the reads. Does that make sense? The other piece that's often neglected is when you do a write to a database and then you do to a read, there is lag in terms of the replication of the data from the write to the reads. So we have lag detection to ensure that your data is always fresh. If the read has not the read data has not been propagated to the read database servers, we're going to continue to read from the write server until all the data is synchronized. So we have lag detection as well. The fourth use case, which is not so much performance, but it's security, is that we can do auditing for privacy compliance. GDPR, I don't know if you guys do any business in the EU, but that is looming in May. And that has to do with data protection for the EU citizens. And we help in HIPAA, PCI, GDPR compliance in the sense that we log everything for the customer. We log who accessed what and when as well. So our visibility, data visibility, because we see all requests and responses, is very, very good. Any questions about these use cases? It's all part of this one database proxy. Okay. Let's get into caching into Redis. What Heimdall Data can do is, again, it provides automated SQL results caching in a distributed way on the application server. And I liken it to L1, L2 type of caching. What it's going to do is it's first going to cache in memory in L1 the hot objects. And anything remaining, it will be cached into Redis. So it's L1, L2. So the gentleman had mentioned one of the most difficult things is invalidation. Okay, so you've got caching figured out. If there's something that's a duplicate common requested query, that's something I'll cache. Okay, I get that. But what happens when there's an update to the table? What happens is that whenever there is a write to the database, the Heimdall Data proxy for that particular server will communicate to Redis, and Redis will invalidate that table and communicate to all the rest of the local caches that that table should be invalidated. So it's all automated. There's no more expiry or TTL to configure. It's just a click of a button, and all these Heimdall Data proxies will communicate together, aggregate together as one single cache that's going to cache into local memory, into your Redis cluster. Again, this is SQL results caching. It's a type of look-aside cache. Okay. Any questions here? Yes. Good question. I think you should get the mic. Yeah, I don't think the mic's on, Lee. The question was basically, does Heimdall Data use the Redis pub sub to communicate to all the Heimdall Data proxies when an invalidation should happen? The answer is yes. So instead of creating a proprietary messaging bus, don't reinvent the wheel. So we use pub sub of Redis, and Redis basically communicates to the local caches to invalidate that table. Okay. Any other questions? And it's all built in. All you basically have to do is have Heimdall Data point to Redis, and everything gets taken care of. We write to the Redis APIs. Okay. Yes, there's a question.
Sorry, me again. How does this layer handle locking and transactions? So if you've locked a database entity and then you're doing subsequent operations inside that same transaction, do other applications get blocked?
Okay, so what happens if you lock a transaction? So what's going to happen there is we do have a buffer in which you can buffer, and there is a capability that we have that you could block it, but it's not recommended. Okay. And when you lock a table, by definition, it's not recommended because then you sacrifice on performance. You can't have it both ways, right? If you want very, very tight data integrity, then you sacrifice performance. If you want ultimate performance, then you're going to have some issues of, of not locking. You can't have it all, right? And you need that balance. Yes. The question is there any lazy load capability? Let me talk to you offline about that. Okay. The simple answer is no, but no, there isn't. So let's put this all together in terms of a high-level architecture. We're supported in Azure, AWS. So if you're using Aurora, RDS, SQL Server, any SQL database, we're completely transparent. And we sit in the application server. So if you have 3 application servers, it's distributed. You have 3 database proxies. And these are all being centrally managed by a central console. And that central console could be anywhere you like. And I'm going to show you a demo of the central console. We do the SQL analytics and the logging. Even just the logging and the analytics is worth the price of admission. I think it gives you a lot of visibility on what's going on. That one proxy will auto-invalidate, auto-cache. It will do the automated failover, and it will do the read-write splitting, and I'll get to that in a second. So Heimdall will intercept and forward the SQL traffic between the app and database. It will cache results only if it provides a performance benefit. Okay? So we just don't blindly just cache everything and cache if it doesn't provide a performance benefit. We'll go through some algorithms, and if it's faster to get the data, read the data from the database, then we're going to do it, as opposed to reading it from cache or reading it from Redis. So we will make sure that when we cache, it's going to provide an application response time benefit. And then as mentioned, we ensure data consistency, all without any code changes. We use real-time analysis and statistics based on the query frequency and the variability. As I mentioned, we compare the relative performance of the cache and the database of retrieving that data. And again, we auto-cache only if there's a performance benefit. Now, if you don't want us to auto-cache, we can also provide recommendations. Just like the top 10 music hits, we can provide top 10, top 100 queries to cache, and you just click the button. So it just makes it very simple. We can cache everything. You can cache everything on aggressive knob, or you can cache some of the recommendations, or you can cache none of them. For microservices, we're a great solution as well. The microservices would all be talking to a centralized proxy within the application server. That's one way to deploy it, or you can put a proxy in each microservice or each container, for which it does the caching, it does the high availability and the routing, if you'd like. There's many, many ways to deploy a database proxy, and it's great for the future of microservice architectures. Some other features that I haven't mentioned is that we can do connection pooling. So if you don't have a connection pooling solution, it's included in there as well. Okay. So a customer use case, Movietimes.com was on AWS, and one of their challenges was that they had a huge surge in traffic, especially when it's seasonal, to buy tickets, and it was overloading their database. And one of their challenges was it was too expensive and too timely to create a caching solution. If any of you have developed a caching subsystem, it's not easy. We've done a survey, and it takes about 20% of developers' time annually to not only create but maintain a cache subsystem. Okay, it's a lot of work. And so they chose Heimdall Data because we were able to diagnose and cure SQL bottlenecks very quickly. And with one click, we got them online with caching. So they built a cache subsystem in one day and started testing it. And in this case, they use Amazon Elasticache, which is Redis based. They used the Redis for Amazon Elasticache. And the benefit is they got a 10 times increase in database scalability. They saved 2 developer resources, and they installed in 1 day. 1 day versus 8 months, that's the benefit of a database proxy. Any questions about this use case? Yes.
How do you handle the changes, because news websites like Movie Times, any website, especially if it is a news website, there'll be a lot of changes on the website. So how do you handle that with whatever use case you're talking about?
Thank you. So the question is how do we handle if there's a lot of changes to the database? In other words, there's a lot of writes. The answer is relatively simple. By definition, caching only makes sense and adds a benefit if it's very read-heavy. So if there is a lot of writes to the database, then our algorithms, or even the developer, you're not going to be caching that data because it's constantly changing and it's very inefficient. So our algorithms, if we see the variability of those queries, we're not going to cache it. It's got to be duplicate queries, and it's got to be not only constantly asked, but the data isn't changing. So by definition, caching is read heavy, right? Any other questions? Okay. So let's go through a few use cases, and then I'll go through a demo. So the first one, is anyone deploying hybrid clouds out there? Where you may have a database on-prem, and then you put your application in the cloud. This is a great use case. As you know, this is what I talked about in the beginning, is that this is where the application database becomes geographically dispersed, and maybe your company just isn't comfortable of migrating completely to a cloud, to a full cloud solution, so you're going to keep the sensitive data on-premise. Well, because Heimdall Data caches at the application side, a lot of those queries that would have gone to the database are being served out from Redis or served out from the application tier. So that back and forth round trip time is eliminated. So from a hybrid cloud perspective, a database proxy could be very, very beneficial because you're caching SQL results from an application perspective. The second one is horizontal scale out. Just want to reiterate here, as you're scaling out your data tier, you want to separate your write servers from your read servers, okay? So a database proxy would be SQL aware. When it sees a read, it's going to go to the read servers and get the data, and it's going to load balance across there such that if there was a failure to any of the read servers, it would automatically fail over, which would be transparent to the application and to the user. And the writes would go to the writes. I also mentioned that there is also lag detection, just to ensure that whenever there's a read, it's going to ensure that the data is always fresh. So if the data hasn't been propagated to the read replicas, it's going to read it from the right server. Okay? And then lastly, the use case is end-to-end SQL analytics. I hear this all the time from customers. I don't know how big your company is, but the DBAs and the application developers often are in contention when it deals with application performance. The application owners always is a strong term, in many, many cases, would point to the developer, to the DBA and say, you know what, it's the schema. It's the database that's the issue. It's the SQL that's the issue on your side that's causing the application issues. And my customers, internal and external, are suffering from that performance. Take care of it, DBA. DBA looks at the database, looks at the processing time, and says everything's fine here. It's your code. So it gets thrown back over the fence, and it says you need to correct your code and have better SQL programming. So they point the finger at each other, and they look at their analytics on both sides, and they could all make an argument that it's fine. So what Heimdall Data can do is, because we're performing SQL analytics and performance from an application perspective, we see the request and the response. So we see the full transaction. We have full visibility of where the SQL bottleneck is. Is it on the application side? Is it on the database processing side? Maybe it's neither, and it's a cloud latency issue. So you can pick apart where the issue is and then hone in to debug it and solve the issue. And I'll show you a demo of that. Any questions before we get in demo? Yes?
Schema changes are handled automatically. You add new columns or drop columns and
Oh, so your question was, do we do schema changes?
if we do schema changes on a large database,
Yes.
it automatically invalidates anything else that you may be serving from there?
Yes. Yes. No, well, so let me qualify that. So in a case whereby there is a change to the database, that assumes that it went through Heimdall Data first. So what you want to do, best practices, is that any data access is going to go through a database proxy first. So if there is a write to the table, Redis will communicate to the local caches that it's been invalidated. Okay? So if there is a case, yeah.
Alter table, you add a column, it will go through Heimdall Data first.
Yes. Then we'll do the invalidation. We'll do the invalidation of the cache. Okay. There was a question in the back.
Application, let's say your example is if the application is writing into the database, that's when you are invalidating the cache. What if the data is coming from upstream system directly to the SQL database, how the invalidation will work at that
Okay.
time?
So let me repeat the question, because that's a great question. So this gentleman has, well, what happens in a situation whereby there is an application that has direct access to the database and it doesn't go through a Heimdall Data proxy? How does the validation occur? Well, I will try to repeat it again and say that best practices, you would have a database proxy on every application. So, yeah. Right. Well, let me try to answer it first. I haven't answered. That's best practices. So if it doesn't go through a Heimdall Data proxy, is that what your question? And it does a write to the database table, then how do you invalidate? Is that the question?
There are some other applications who are actually writing to the database and we are just consuming that data.
Yes.
So in that case,
yes.
So they also have to have the Heimdall Data.
Yes, that's best practices. And so let me get to your answer now. In the situation where the customer would say, well, it's just fact that we have an application that writes straight to the database, and it's not going to be going through a database proxy. Okay? In that situation, if you're not going to put a Heimdall Data proxy there, we have the solution would be you would put a database trigger, for which we would poll the database and see get any updates when there was a change to the table. If there was a change to the table, Redis would then communicate to our caches or to Redis to invalidate that table. Did I answer your question? Okay. Good question, though. Yes?
So I want to ask about deployments. Yeah. You have integration with Google Cloud, I think.
Do I have integration with?
Google Cloud databases. So is it like a replacement for their own proxy, which they ship for example, Kubernetes deployments? Or you just make your proxy in addition to their proxy?
Okay, so the answer is whether Google Cloud, Azure, or AWS, or wherever you want to deploy, even on-prem, we're just an add-on. It's not a rip and replace. It's not only Heimdall Data, but any database proxy out there, it's just an add-on. So it runs as a separate process. It runs as a JDBC driver. It's an additional jar file for JVMs. And it's going to sit logically in the middle between the application and your current existing database. So it's not replacing a database. It's not replacing anything.
No, I mean, Google ships its own proxy to connect to like central database they have like as a service. So I mean, this will be seed between application and Google proxy.
Yes, it would just you would shim right in. And it's just a IP and port. It's just a networking connection that points to us, and then we'll point to the database. Okay? Yes, sir.
Two questions. First one is two quick questions. First one, with regards to if you have an ORM sitting in between, is it doing any optimizations on the queries that it's performing?
Okay, you want me to answer that one first?
Yes.
Okay, the question is, if you have an ORM, what impact does that have on a database proxy? Absolutely zero, okay? So let me just, zero impact, negative impact. So an ORM, let's just say for Hibernate, for example, I'll use Java. It is going to do its SQL translation and do its magic there, and it actually has caching at the entity level and at the SQL level, but here's the big difference. You need to choose and figure out what to cache and what not to cache, and you need to know when to invalidate. So what we recommend is if you want to do your caching there and have a Hibernate for the SQL, you can have Hibernate. We sit at the data access layer. So whatever is going to come in terms of SQL, in terms of database access, we're going to add additional benefits of routing, failover, and caching. We're going to catch whatever you didn't cache. And we've seen that before where people think like their code's really tight or they use Hibernate to cache, and they're really surprised that our auto caching, because it's all math, algorithms, we catch a lot of things that they didn't, they missed the cache.
Sure.
And we add extra benefit.
Okay, that sort of answers the second question. But you were saying that as far as what to cache, it auto detects and is constantly querying and determining that. Can you put more controls on particular queries if you explicitly want them cached or not?
So you have full control of caching. Caching is very risky. We can give you recommendations, and you can take some of the recommendations, you could take none of the recommendations, or you can write policies and regex on what you want to cache. You can go aggressive mode and say, you know, like in IT, they don't even want to think about it and say, Heimdall Data, I want you to cache everything. And we recommend that because that's the safest and the most efficient. We'll just cache everything, and then we'll do the invalidations. So it's totally configurable. Now, there is one question I'm surprised no one asked, which people typically ask, is the memory configurable because of the L1 cache in memory? Absolutely. It is totally configurable, and will cache the L1 memory to whatever you configure to. You'll be surprised that for hot objects, what we've seen is that it's about 50 to 250 megabytes for hot objects. It's relatively small due to the efficient caching, and such that everything gets, you know, in terms of the non-hot objects, the residual goes to Redis, and sometimes Redis isn't even used for a lot of the caching because it's just so efficient. And Redis is used for the invalidation messaging bus. Yes?
Hi, so you mentioned you catch everything for a database. So how can you calculate how much memory you need for that cache based on your current database size? How can you judge how much memory you need for that caching?
Yeah, you know, great question. So basically, how do you do capacity planning for memory? That's your question. Well, obviously, as a developer or DBA, you should have some intimacy with the behavior of your writes and your reads, and so you would know best about your capacity. But we can give you some best practices, and what we've seen is for L1 memory, it is very negligible. It's at the megabyte range, and then the remaining would be cached into Redis. So it is very application dependent, but for us, we deal a lot with online applications, and 250 megabytes is sufficient. But it could vary. It can really vary. That's up to you guys to do the capacity planning. You configure it, and then we'll make sure that it stays at those boundaries, those caching boundaries. Yes?
So suppose that you're in a distributed system. Say you have 2 app servers in one database. How do you cache between both servers? If I have a request that goes through server 1, if the next request goes through server 2, will that somehow have the cache, or will it just need to cache it again?
Great question. Did you guys get that question? Did you guys understand that? I'll repeat it. That's a good question. So for every application server local cache, it is completely independent from the other local cache. So the local cache of app server 1 could be very different from app server 2. What really matters is the invalidation. So if app server 1 has a write, an update, that's when Redis needs to communicate to all the other local caches, invalidate that table. Otherwise, all the read data for the local caches could be different, and it doesn't really matter. Because behavior from one app server could be different from the other app server, if that makes sense. Okay? Good question. Yes?
So you explained the use case 2, right? Can you quickly go back to your use case 2, where you mentioned about the horizontal scale-outs?
Yes.
The question here is like, for instance, if we have a SQL always-on cluster setup in our environments, how does this scale-out overlaps or interoperates with that, or does it overwrites it? Because we will have some routing options already enabled as a part of the always-on setup.
Okay.
So how does it overlap?
Okay, great. We are SQL Server cluster aware and work with always on. Okay, our failover would be faster. So in many cases, for SQL Server always on, it could be many seconds, tens of seconds, or minutes. What we're going to do is that we're going to make the failover faster. That's one piece. The other piece too is this is all configurable, but what we would do is we could detect like a Galera cluster and then also a SQL Server always on cluster. So we would know what gets promoted, which one's the write server, which one's the read server, and we'll route to it. And you can also create policies for that as well. So we're always on aware. Does that answer your question? Okay. Any other questions before we get into the demo? Okay. Good questions. Okay, what I have here, I'll give a quick 5-minute demo, is there is a Postgres-based application. It's an e-commerce application called Odoo, O-D-O-O. And this is an online app, and you can do shopping with it. I'm going to buy an iPod. And then I'm just do a few queries here, an iMac, an iPad mini. And what's going to happen is we're going to read the console. And I have a load generator here that constantly is just doing those transactions. And I kid you not, I'm going to take a look at your right, upper right-hand corner. This is very common. This is cache hit rates of 95%. That means only 5% of the queries are going to the database. 5%, everything else is going to Redis. Okay? What does that mean to your organization? If you're a SQL Server deployment like this, what this gentleman mentioned, you're saving a lot of database licenses because SQL Server is commercial. Okay? 95% cache hit rate. What that also means is that the application response times from the database is a lot faster, a lot faster. Okay? So cache hit rate from a Redis standpoint, this is really good. 95% cache hit rate. The other piece that I would mention to you is if you look at the in the middle here, upper middle, you'll see the query time is about 1,000 microseconds, or let's just say a millisecond. Now I'm going to stop there. Let me hold on a second. I'm going to do a pause. Now the blue is the caching, and overall it's about 10 microseconds. So we went from 100 milliseconds to 10. So that's a 10 times improvement of query time through caching. So you're getting a cache hit rate of the majority of the reads, 95% of the queries, sorry, of all the queries, and you're getting a 10 times improvement on the average query time. That is pretty cool. No code changes, no database changes. It's a database proxy is dropped in literally, it's not a marketing thing, 5 minutes and you're done. That's pretty neat. So you get a dashboard basically here of what's going on in your queries per second, your average query time, your cache hit rate. Let's go to BDB. Let's go through some configurations here. Caching, anyone deployed in AWS? Okay, in AWS, really neat. There's a wizard here, and what it does is it auto-detects your current AWS components. So if you have Aurora, you have Elasticache, you have CloudWatch, it's just going to become a drop-down menu in this wizard. So in this example here, you could choose how you want to cache. For today, we choose Redis. Okay? So you choose the storage of your choice. If I were to erase this, check this out. It'll cache into Redis Cloud. Anyone in Redis Cloud? If not, shame on you. I recommend it. We're partners with Redis Labs. So you can connect straight to Redis Cloud on this GUI. So this gives you full freedom of whatever cache you want to deploy. Let's move on here. Here's the list of the various databases that you choose. Very, very easy, all drop-down menus. And again, in AWS, it would be an auto-detect. So it would auto-detect what you're connected to, and you just choose the appropriate RDS or Aurora database. In here, it would have the cache. There would be Elasticache if it detected it. Okay. Let's go to data sources. Basically, you would put your, because we're written in Java, you would choose your JDBC driver. We support connection pooling. We support load balancing as well. You do your configuration of the connection hold time, of when you want to hold before you fail over. So the other thing too about failover, of why our failover is so good, one of the reasons why is that we minimize the number of application exceptions. When we do the failover, we will buffer all the requests, then fail over to the replicate database, then take all of that was in the request in the buffer and fail over, such that the application or the user wouldn't even know that there was a failover. Okay? Not only is it fast failover, but it's also buffering such that you have as few application exceptions and errors as possible. And this is all configurable. Let me get to the analytics because my time is running out. This is really the money shot here. What we're doing here in the analytics is it tells you what is being cached. In this little icon here, all these small little icons is telling you what is being cached. All those are being cached. It tells you 5.1%. This query that's being cached represents 5.1% of all the queries that is going to the database that is being cached, or going to cache that's being returned. It gives you the cache hit rate, the number of queries, the overall response time, a lot of good information that I can't go through now to figure out, is this SQL bottleneck a problem on the database server side or on the cache side? We also have, you're going to love this, not only the query that we show you, the full query, but we also give, oh, hold on a second. Let me see if there was one here. We also give the query plan. And I'm just wondering from an app developer perspective, is a query plan, the execution plan, something of interest to you guys? So in one single pane view, you also have not only the queries that's being cached or the slow query that's being cached or redundant query that's being cached, you have a query plan, the execution plan. And you can figure out from there if there's any issues that you can optimize as well. Okay? You have full view. Okay? Gives you stats. Lastly, what I want to show you is if you click here, let me look at a line here. Let's look at the select product template ID. We see that the cache response time is about 339 microseconds response time from cache. Now, if I click on cache statistics, what it's going to tell me is the response time of the database now. I'm pulling stats of the database response time or the processing time. And here, what do you see? It's 0, or next to nothing. So if I have 330 microseconds from an application perspective response time, and it's 0, relatively speaking, 0 on the database side, what can I say the latency is coming from? Where is that 339 coming from? Network. And that's how you deduce it. I know the application side. I know the database side. From that, you can deduce that it's the network. Then the question is, how do you solve that problem? We would recommend a database proxy, but if you want to do it yourself, you can cache effectively to remove that network latency. Does that make sense? This is a very, very good tool, not only from a caching, auto failover perspective, but also from a visibility perspective, is what is going on with my SQL as a developer? And where do I optimize it? Is it on the database side, application side, or is it network latency side? And with that, I think my time is expired. Any questions I can entertain before we end? Thank you.